So today we will going to solve a problem of a lowest common ancestor. In this question we have given three things. One thing is root of a binary tree and another we have two root node. So what we need to figure it out, for we have given two node and we have to figure it out lowest common ancestor. I will tell you by an example. Suppose you have given two node 5 or I can say 8. So in simple word I can say you have to figure it out the lowest common parent for both these nodes. And what is the lowest common parent? It will be 3. So here 3 would be an answer. And similarly, like if you have given two root 6 and 4, so what is the lowest common parent for both these nodes? It would be 5. So 5 would be answer. It is the lowest common parent. And another example would be like you have given a node 5 and I can say 1. So what is the lowest common parent? It would be a 3. But there would be one edge case, like you have given two node, like one node is 5 and another node is 4. So what is the lowest common parent? You may think it would be a 3, but it is not correct answer. You have to ask lowest common ancestor. So for both these nodes the lowest common would be 5. I hope you understand. Similar, like if two node would be 1 and 8, so the lowest common would be 1. So we will solve this problem using simple recursion in a big of n time complexity. So what we can do in this question, we will figure it out two things. We will make two call for every node, for every root node. So what exactly we need to figure it out? From left hand side, what we need to figure it out, we need to return is there any value present, either P or either Q. We need to figure it out from left. And similarly from right hand side also we need to figure it out, is there any value P or Q is present. And by the way, all the value of the binary tree are unique. It is given in the question, so it is no duplicate value. So from left hand side what we need to figure it out, is there any root value which is equal to P or equal to Q. And from right hand side also we have to figure out both these things. So suppose that we will take the same example here as well. So from left hand side you have to figure it out that there is a P root values is present. So from here we will return 5. And from right hand side also we will get 1. So we will return 1 from here. And if our left and if our right is not equal to null, that means we will get the right value also and left value also, then we will directly return root. And it is one case. Another case should be like your P and Q value would be, suppose you have given P value 5 and your Q value would be 4. So what you can say, you will make a left code. From left code you will figure it out 5 would be there. So from here you will return 5. You don't need to search extra from here, because if you search extra from here, if you find value 4 would be there, then your answer would be a 5. So you don't need to search extra in this space, you will directly search in the right hand side. And from right hand side you will not find any value which is 4. So from right hand side it would be a null, you will return null. And from left hand side it would be a 5. So if your right hand side, if your right hand side would be null, so you will directly return left root. I can say you will directly return left node. I hope you understand this. And similarly, like if you figure it out, similarly if your P value is equal to, I can say 8 would be there and your Q value would be 1. So what you can search, you will search from left hand side, and you did not return anything from left hand side because you don't get any 8 or 1 value, so you will return null from here and from here you will search any p and q value, and you will figure it out that yes, you will present this value which is equal to this. So from here you will return 1, and you don't need to search here in this space, because if you will get the value here, then there is no mean that the answer would be this one, because you have to figure out the lowest common ancestor and the answer would be 1. So similarly, if I can say if from left equal to null, then you will directly return right, and if both are null, then you will definitely going to return null, and if both are not null, suppose from here as well you will return some value. Suppose that in our what we have given the question 5 and 1, so you will return 5 and you will return 1 from here. If both are not equal to null, then you will return root exactly. So how our code do like, I will tell you this one. Our code look like this. So in the function you have given 3 things. One I can say a root, and one is p, and one is q. So what exactly is base case? Base case would be if your root equal to null, or your root equal to p, or your root equal to q. So you directly return that particular root. Suppose we have taken an example like this is an example. So suppose that your p value would be here 3 and q value would be here, I can say 4. So for every node you can make 2 call, left would be and right. For left you can traverse the left hand side, and from right you will traverse the right hand side. Suppose that you will make a call at present here, and your value for this call, your root value would be equal to p, so you will return this particular value. So from this side you will return 3, and from the right hand side you don't find any value which is equal to 4, so what you will return? You will return null from here. It means your q value will be present left hand side, and if this happening, that it mean that the answer would be your left node, it means this one. So if right equal to null, you will return left. Similarly, like the case would be like this one, if here 1 would be present, if value of p would be 2 and value of q would be 1, so from left hand side you will return null and you will actually return right. And if this one not case, suppose that your left is not equal to null and your right is also not equal to null, then you will directly return root from here. This is a very simple approach, and the time complexity would be definitely be big of n in a worst time complexity. It is the worst case, because suppose that you have given this node and you have figured out this one, so you don't need to search here. So it can be reduced time complexity. So your worst time complexity would be big of n, and similar like for space complexity it would be big of n. I hope you understand this.